So now we're going to be simplifying expressions with product property. So we're still simplifying radicals, simplifying radical expressions. And the method a lot of times they'll use is the rule that the square root of a or the nth root of a times b can be written as the nth root of a times the nth root of b, where you have to find a perfect root that goes into the number, just like with a square root. When we had, say, square root of 8 can becomes the square root of 4 times the square root of 2, and then the square root of 4 is 2 times square root of 2. The way we simplified this, the majority of the time you either did the factor tree or birthday cake. I'm going to do the same thing, and we kind of started it on the last notes. It's just depending on the index, in order to pull one out, you need to have the number of whatever the index is, or the root. So if it's a cube root, you need 3 of the same number. If it's a fourth root, you need 4 of the same number. So here, these are very similar to the ones we did in the last section, but all the ones in the last section, the root or index went in evenly to all the exponents, and it's not necessarily going to happen that way for these. So for this one, a lot of times what I like to do is do it separately, and I can do this using that product property, basically using this rule. I can separate each of them being multiplied. So the square root of 25 is 5. I don't have to do any work for that if you know it. The square root of a to the 4th is a squared, and it goes in evenly. 2 goes into 4 evenly twice, so there's nothing left. And this one, 2 goes into 9 4 times. So it's b to the 4th, but it doesn't go in evenly. So you have something left inside the radical, and it's going to be b to the 1st, because 2 goes into 9 evenly, and that's 8, and it's the remainder that's going to be left on the inside. So it's 5a squared b to the 4th times the square root of b is my simplified form. So for this one, the cube root of 125, if I do the birthday cake for this one, divide by 5, and that's 25, and you may start seeing this is just going to be, and it's a cube root, so I have a group of 5, so that's 1 5 comes out, nothing is left on the inside. It's going to be a lot easier. You won't have to do this if you know your perfect cubes. They're all in your foldable. They should be, to get familiar with those. So when I do the m, I'm basically simplifying this cube root of m to the 30th. 3 goes into 30 evenly 10 times. So that's m raised to the 10th with nothing left on the inside. And when I do the cube root of p to the 20th, 3 goes into 20, that's going to be 6 times, and 6 times 3 is 18, which means there's a remainder of 2. So I have the cube root of p squared that is left, and that's going to be my simplified form. Go ahead and try these two for you try problems, and you can pause it and I'll give you the answers. I'll go over it in a second. Pay attention to, remember the absolute value rule. If it's an even root and you pull it out and your result is odd, you need that absolute value. So for this first one, you should have gotten 2 c to the 3rd, d to the 1st, and both variables are odd exponents, so they should have the absolute value bars on them. And then they're still being multiplied. If you want to put the multiplication sign, you can, times the square root of, there was a 3 left over that's on the inside, and d to the 1st left over, because 2 goes into 3 once, but there's a remainder of 1, so that d stays on the inside. And for this one, 3, the cube root of 27 is 3. 3 goes into 12, 4, so that's y to the 4th It goes in evenly, so there's no y's left on the inside. And 3 goes into 7 twice, so that's z squared. And there's a remainder of 1, so it's the cube root of z that is left. So this rule, the quotient property rule, says the nth root of a divided by b, you can separate that into the nth root of a divided by the nth root of b. Basically the same thing as the other one. When you're multiplying things inside of a radical, they can be separated into two radicals. Same thing with division, they can be separated. So this, and it works both ways. The square root of 27 divided by the square root of 3 would become the square root of 27 divided by 3, and all of that can go under the same radical, and then 27 divided by 3 is 9, so the square root of 9, and then that could equal 3. Same thing here, you can separate this into the cube root of x to the 6th over the cube root of 8, and then those each can simplify. The cube root of x to the 6th would become x squared, divided by the cube root of 8 is 2. The difficult part with these is that you have to rationalize the denominator, which means I can't have a radical in the denominator. So when I separate this, and this becomes the square root of y to the 8th over the square root of x to the 7th, I can simplify those, and that becomes this is a 2. 2 goes into 8 4 times, so it's y to the 4th, divided by 2 goes into 7 3 times, so it's x to the 3rd, and I had 1 left over, so it becomes square root of x. But I can't leave this radical inside the denominator, so I have to rationalize it. And with the square root, it makes it pretty easy because I just multiply it by that same square root. Square root of x times square root of x, that's going to become square root of x squared, which then will simplify. And if I multiply it to the numerator, to the denominator, I also need to multiply it to the numerator. So I'm going to come down here. This becomes y to the 4th times the square root of x divided by, I have x to the 3rd, and this is going to be square root of x squared. Well, square root of x squared becomes x, and that's going to be multiplied with x cubed. So then that's going to be y to the 4th times square root of x all over x to the 4th. The cube root makes it a little bit more difficult because you have to get it to a perfect cube. I'll go ahead and show you the way that I try to work it out and try to explain for you to do it. If you're having trouble with this, let me know in class and we can talk about it more in class. But let's separate it first. It's the cube root of 2 over the cube root of 9x. The cube root of 9 is not a perfect cube. It doesn't come out evenly. So I need it to come out evenly. And sometimes you may see it, but if you don't, go ahead and factor the 9, whether you're using the birthday cake or factor tree. You don't want any left over. So I have 2 3's, but for a cube root, I need an extra one. I need it to be 1 more. So when I multiply, I'm going to multiply this with 1 more 3, and then that's going to make that 3 3's, so it comes out to a perfect root. I also only have x to the 1st here. I need it to become the cube root of x to the 3rd. So what I'm going to do is I need this to be multiplied with the cube root of x squared, because what I do with the exponents here is I add them. So this is going to be 1 plus 2 is 3. So I'm multiplying this by the cube root of 3 x squared. And when I simplify that, I can multiply these together, both cube roots. 2 times 3 is 6, x squared over, and this becomes the cube root of 27x cubed. And then 27x cubed, the cube root of that simplifies to just 3x. Cube root of 27 is 3. 3 goes into 3 once. There's nothing left over, and that was my goal. So I didn't have any more radical in the denominator. And this does not simplify, so it's just cube root of 6x squared. Again, I'll use these two as your U tries, so go ahead and do your best, and I'll go over them in 5 seconds. So these are your two answers. I've shown the work. I'll go through it in the process. This first one, separate it first, square root of a to the 9th over square root of b to the 5th. Simplify both of those. I still have a square root of b, so when I multiply that with the square root of b to both top and bottom, numerator and denominator, this becomes the square root of ab. I'm still multiplied with that a to the 4th. This is b squared, and this part here just becomes square root of b squared, which is b. And then b times b squared is b to the 3rd. So that's how I get this answer here. This one is a little bit trickier. It's the 5th root. So I can't simplify 4y. So I fixed that mistake. This was just y, not y squared. I had written it as y squared. So when I factored the 4, I have 2 times 2. And I need 5 of them for a 2 to come out of that radical. So I had to multiply 2 times 2 times 2 in order to have a group of 5. Well, 2 times 2 times 2 is 8. So what I did was I multiplied by the 5th root of 8 to both numerator and denominator. And to get my y to the 5th, I had to multiply it by y to the 4th. And so both numerator and denominator. This denominator became 5th root of 32y to the 5th, which simplifies to just 2y. So I'm not quite sure what number we're on. We'll call this number 9. The other ones I think were lettered. Well, if we did it individual ones, including the U tries, I think it was number 9. So simplifying radicals, multiplying radicals here. When you're multiplying two radicals, they have to be the same index. They have to be the same root. So in order to do so though, we multiply what's in front. So 5 times 3 is going to become 15. And then you multiply what's on the inside, and it's going to be negative 12 times 18, which is negative 216. A times a squared becomes a to the 3rd, and b to the 4th times b squared becomes b to the 6th. Remember, when you're multiplying, you add the exponents, the coefficients I multiplied. So when I'm doing the cube root of negative 216, first I have to decide, am I even allowed to do that because it's negative? But because it's an odd root, I am, so I'm good. And I can start breaking this down. I'll do the birthday cake, 2 and 108. 2 and 54, 2 and 27, and if you notice here, 27 is a perfect cube. It's going to be 3 and 9, 3, 3, and 1. And so I'm looking for 3 of a kind because this is a cube root. So I have 3 3s, 3 2s, so what comes out is going to be 6. And that 6 still has to be multiplied with this 15 that's already out there. So 6 times 15 is going to be 90. And let me simplify the variables now. I have the cube root of a cubed. Well, that just becomes a, nothing left over. 3 goes into 3 once, nothing remaining. And 3 goes into 6 twice, so that's b squared. The one thing I did forget is this was a negative, so it's negative 90 ab squared. So adding and subtracting radicals is different in the sense that you have to add and subtract similar to like terms. The radicals have to be like terms. So I'm going to say to add or subtract radicals, you must have the same radical, including both the index and the radicand. So here, the square root of 3b and 4 square root of 3b, these are like radicals. Where here, this is the square root of 3b and this one is the cube root of 3b, these are not. And these are not alike either. They're both square roots, but one is 2b, the other one is 3b. The radicand, what's under the radical, has to be the exact same, and it has to be the same index or the same root. So something like this, it doesn't look like we can add or subtract them together, but you first need to simplify it to see if they simplify into the same radical. So I'll do the factor tree with 98, and I did the birthday cake with 32, and what ends up happening, this becomes 7 square root of 2 minus, I have 2 pairs of 2's on this one, so that's going to be 4 coming outside, but I already have this 2 out here, so it's going to become 4 times 2, which is 8, times the square root of this 2 that was left over. And so now they are the same radical, and I can subtract them, and at this point it's just 7 minus 8 times the square root of 2, and you do it just like you would 7x minus 8x. 7 square root of 2 minus 8 square root of 2, that becomes negative 1 square root of 2, or negative square root of 2. To multiply radicals, something like this, we did the monomials, this is kind of binomials, and we need to FOIL at this point, combining more than one thing that we've already done. So I have 4 square root of 3 times 3 square root of 2. Well, I multiply the 4 and the 3, and that becomes 12. And multiply the radicals, square root of 3 times square root of 2 becomes square root of 6. And then I have to do 4 square root of 3 times negative 6. Well, because that's not inside the radical, I'm going to multiply it with the 4. And so that becomes negative 24, and there's no other radical, so it just stays square root of 3. And then 5 square root of 2 times 3 square root of 2, that becomes positive 15 square root of 4. And 5 square root of 2 times negative 6 is negative 30 square root of 2. All right, change of scenery here. So now we can go ahead and combine our like terms and simplify. Well, none of these are like terms. I have a square root of 6, that doesn't simplify. A square root of 3, that doesn't simplify. And a square root of 2, that doesn't simplify. This square root of 4 does simplify, but it simplifies to just 2. Not the square root of 2, but 2. So what this is this is 15 times 2, which is going to be 30. And I'll go ahead and put that one first. And then none of the others simplify, so I can't combine them. So you just leave it plus 12 square root of 6 minus 24 square root of 3 minus 30 square root of 2. And that's the simplified form. If they are both the same, then you would be able to combine them, but none of these are, so that's it. I believe this one is number 12, and we're going to be dividing, and I have a radical in the denominator, so I'll need to simplify it and rationalize the denominator. Well, right now I can't simplify anything at this point, so all I'm going to do is rationalize the denominator. And a lot of times that's all you really need to do. So because it's a binomial, I'm not just going to multiply by the square root of 5, because I will still end up with a radical here. When it's a binomial, you're going to rationalize it by multiplying by the conjugate, just like the conjugate with the imaginary numbers. So the conjugate of square root of 5 minus 1 is going to be the square root of 5 plus 1. And so I have the square root of 5 plus 1 that I have to multiply to the numerator as well. Because when I multiply conjugates, it's going to be a rational number in the denominator. So because this is just a monomial multiplied with this binomial, all I'm doing is distributing, so it becomes 2 square root of 5. This is not in the radical, so I can't multiply it with 5, I just multiplied out in front, and then 2 times 1 is 2. Divided by Now this is my FOIL part. Notice that they are two binomials, so it's going to be the square root of 25 plus the square root of 5 minus the square root of 5, and then negative 1 times positive 1 is negative 1. So I simplify that. 2 square root of 5 plus 2 divided by this becomes 5. These two will cancel out, and minus 1. So then I go ahead and simplify that. Two square root of 5 plus 2 divided by 5 minus 1 is 4. And if you can simplify, remember you're looking at all three parts here, and they can each be reduced by 2, so this is 1 square root of 5 plus 1 divided by 2, and that is my simplified form. And I don't have a radical in the denominator anymore, so I am allowed to leave it like that. So here are 3 more U tries. Go ahead and give these a shot, and I'll have the work for you and the answers here in a little bit. So here are my 3 answers. 16 square root of 3 minus 8 square root of 2. And then this one, nothing combined when I multiplied them all out. And this one simplified to 27 minus 10 square root of 3 all over 13. If you got them right, great. Good job. I'll go over them after this joke. What do elves do after school? Gnome work. I'm running out, man. I'm running out.